this officially. So welcome everybody to this Ask Me Anything session. It's my pleasure to welcome Kathryn McKinley here to answer your questions. Kathryn was a professor at the University of Massachusetts, UMass Amherst, and also at the University of Texas at Austin. She's an ACM and IEEE fellow, and her current work is in data center capacity planning for Google Cloud, trying to balance availability while being a wise provider of the world's computing resources, which aligns well with running a profitable business. Over the course of her career, some favorite research topics have been research management, parallelism, and garbage collection. And Kathryn has told me that she welcomes any questions, but especially on her research interests, on the new CARES committee that she has helped push forward in both the architecture and now in the SIGPlan community, and in general ways that we can make PL more welcoming and more inclusive for people of color and for women, where we have a radical underrepresentation. So please go to the Slack channel. You'll see under the Ask Me Anything thread in that channel, there will be a particular thread with Kathryn's name on it, and you can go to that thread discussion and ask your question. There's several questions there already. Just add yours to the list, and assuming we have time, we have 30 minutes, I'll relay it. Okay, so without further ado, let's get to the first one. This question is by Animesh Chotare. I'll apologize now for butchering names, who's at the University of Florida. And his question is, can you talk a little bit about the DeCapo benchmark suite and the major challenges you faced while creating this suite?
So that's an interesting story because we had started the DeCapo research project to explore dynamic language or Java performance optimization in a dynamic runtime. And we had an NSF review 3 years into our large ITR grant. And we were bemoaning the fact that we had no benchmarks. And they said, oh, you should make your own. And Steve Blackburn, who served to be very research brave, he's like, oh, let's do it. I'm ready. And I'm like, this is so much work. And Steve was like, oh, we should, but we can distribute it. And so you see the 20-person author list. So we defined a process for all of the participants to help collect benchmarks. And then we had some criteria to select them on. For example, you needed to be able to put them in a harness and run them, so you didn't have to have user interaction. We wanted things that people really cared about and were trying to commercialize or already commercialized. And and we wanted benchmarks that helped us solve important problems so that we weren't all working on toy benchmarks, that it didn't matter if you improved their performance or not because it didn't translate into things people really cared about. And I give Steve the credit for both the bravery and the fortitude for keeping us all focused and helping us deliver, because it was really his leadership more than anything that kept us all going. So you have to have someone who's passionate about, I want to make this happen, because it did take like years of work sustaining that process. And Steve is about to have a new release of the DeCapo benchmarks, and that's taken a long time.
Thank you. The next question is from Jubi Taneja from the University of Utah. And she asks, what advice would you give to PhD graduates who are going to work in the industry, but want to get involved in mentoring undergrads or grads through, for example, CRAW or similar platforms? How and whom should we approach?
So so you can talk to people who are on the CRA board and say that you'd be happy to mentor students. One of the best ways from industry to have close connections with students and to help them is to sponsor interns at your own organization and do that regularly. And that's good for your company because it helps you vet new people, and you can hire people who were your interns, and that's a very productive way to get people that everybody works on. And that gives you that one-on-one mentoring experience. There's also some organizations that actually will pair you with people who want mentoring technically. MentorNet is one spot. Mary Fernandez helped get that really effective. And so that's, again, these one-on-one opportunities. And then you come from a university, Utah. So you can make connections with the students there after you leave and keep them up. You can collaborate with faculty. That's one of the things that I do the most still, is have some collaborations with students, with faculty that I've worked with before and enjoy working with.
Fantastic. Let's see. This is a question from Rachit Nigam from Cornell. And he asks, how do you pick research topics? Do you have any advice for grad students when they're picking topics or areas they are trying to develop, and how they can develop their research taste?
So you need ideas. So my strategy here was, especially for new students to help them find topics, is to do this research course where you read stuff and you say, what are the next steps? If you were that researcher and you just wrote that paper, what would you do next? So that you're, instead of trying to start a new area as a fresh PhD, which is super hard, instead you're trying to just see if you can think of the next idea in a good research program. And if you come up with some good ideas, even if like you read an old paper and you come up with an idea that was executed 5 years later, but still you haven't caught up to today, like where they are today, that's a really good sign that you're having good ideas about that area. And then it's very hard to predict what's going to be hot. Like AI is super hot right now. So combining programming languages with AI in lots of different ways, it's good. Like if you can do it, it's really good to like think, okay, in 10 years, what's going to be different, and what can I get ready for what might happen in 10 years? But in terms of my own work, I've worked on fundamental problems that are always there, like garbage collection, compilers. You're always going to need a compiler. You're always going to need a bridge between how people want to program today and their hardware. Garbage collection turned out to be a great source of career satisfaction, where I had what I thought were good ideas and I enjoyed doing it, and the papers got published, so somebody thought there was at least incremental contributions. So in that space, because you always need these things, what are the remaining problems in the area? In an area that's had a lot of progress, it's harder to come up with new ideas, though. So there is a tension there. If you can say, oh, we have this new area, edge computing, how can I apply some existing ideas there? So it's a process, and I read papers, and that gives me ideas. Bill Daly says, try to invent solutions without reading any of the papers, that sometimes coming at a problem with no background, you think of ideas, you're not kind of stuck in the local minima that everybody's thinking. So there's lots of varieties of how people think about being most creative in terms of picking their problems. But you need to like it. Getting a PhD is hard. So you at least need to like your problem when you start.
Great, thank you. So another question is now from Mary Hall from the University of Utah. Kathryn, your credentials combine strong research and leadership in creating an inclusive environment in our field. Can you talk about why it is important to do both? And as a second question, I'll remind you at the end if you forget, did you have a favorite office mate in grad school?
So Mary is my favorite office mate from grad school, although I did have to abandon her for a little while because she was engaged to get married and I had just failed my qualifying exam. And so I really needed to focus on passing my qualifying exams while she was planning her wedding. So I did move out for a little while, but then we were rejoined. All right, now what was the first question is, why do I do both? Why am I?
Why research and leadership?
That's right. So our community, the computer science research community and all research communities are built on, you have to have good ideas, right? And you get the most credibility, the most responsibility when you do good research work. But I've always had a very strong sense of social justice and wanting the world to be a fairer place than it is. So even when I was, and I've always needed a lot of support and a lot of social interaction, which I'm not getting right now, which is a problem for me. But so even when I was a young student, I wanted to go to the women's workshops that they had just started because I felt like, oh, I need support. And I was fortunate at Rice to have Mary Hall, Gina Goff, Marina Kalem, Becky Parsons, who, so I wasn't like the only woman there. And that was really important to my development because I wouldn't have thrived being the only woman because I was like, I'm not geeky enough, I guess, I don't know. So what I needed, I wanted to help give back to the community. And so as soon as I had a little credibility research-wise, I wanted to use it to make the community a better place. And one of the things I did that and you know, that sense of trying to make the world a better place, like even if I didn't have the research credentials, I would have tried because I just, like, I want to feel more welcome than I am. I still have junk happen to me that I don't enjoy. I want our Black friends and colleagues to feel welcome and happy in our community and choose this as a fabulous career. Like, this career is changing the world. Like, computing's really changing the world all the time. And so if we're leaving all these populations out of how we change the world, we're going to change the world in a way that doesn't work for them. And we're going to miss out on the best ideas. All the diversity research shows that when you have different points of view, different backgrounds, different race, different gender, you come up with better, different solutions than if you're just all one homogeneous group working on a problem. So I don't know if that's a great answer, but I have felt that drives me more than anything, right? Just wanting to be in a community that's more welcoming to people like me and people of color.
I mean, I can say from, to inject something about our own personal relationship, I've observed, I mean, I think I got to know you in 2007. Does that sound right?
When you served on the PLDI committee.
PC, right, exactly. And, you know, from that time, you were looking out for young scientists, trying to give them opportunities. I was fortunate enough to be one. But of course, over the years, I've seen that you have a drive to do that in general. You're always trying to find ways to encourage and to help people be more successful. And I think it flips around, you know, you sort of get something back from that as well, right? That is a successful scientist. Some of your success comes from those collaborations that you nurture, from those people that you encourage who solve problems that you couldn't solve yourself. You know, it's kind of a virtuous cycle. So you certainly inspired me to take up this mantle also.
Thank you.
Okay, so on the flip side of encouragement, there's also protest. So another question from Animesh Chotere from the University of Florida was, in your PLDI bio, he saw that you joined Google in 2017. The Google walkout on harassment happened in 2018. How did that affect you? And have you seen any conscious structural changes in response to it?
So I was super disappointed to read with the World, the New York Times article about the Google Android founder being credibly and based on what happened, forced out of the company because of sexual harassment, but not financially penalized. So I participated in the walkout, even though like my group was still having a meeting and they weren't all out there. And and inside Google, that caused a lot of friction. So for example, several of the vice presidents who had a lot of power inside Google had no idea that this had happened. So a lot of what happens with sexual harassment is people try to do things as quietly as possible. And so based on that, in my own org, and my own vice president asked us what he should do. And what I said is, you should get to see all the reports. You should know what's happening, because if you don't know, how do the rest of us trust the system is working? Because they weren't even regularly reporting up to the vice presidents what's happening in the org. So there were structural changes at Google to have more accountability over reports and et cetera. But of course, they don't want us suing them or saying we have a terrible workplace. And so they're still not telling like the rank and file, like how many reports we had this year. But at least somebody's watching it. At least like the hierarchy, the vice presidents get a report of their whole org, so that there is some accountability. And like any large org, could Google do better? I'm sure they could do a lot better. Are they trying? I saw some stuff that looked like they were trying, and then I saw some stuff that they just don't want this to be a big external problem. And so some of the people involved were fired. And so I think that's a tragedy. Do I need to leave my job over it? I need a job, right? So how do you change big institutions? You continue to advocate for change. And so I've done some of that internally. Could I do more? Yes, I could do more.
Okay, thank you. Let's see. Now let's go to a technical question. So this is from Mike Bond from Ohio State University, who you might know. And Mike asked, do data center cloud applications need complete GC, that is GC that collects all garbage, or are the properties of data centers, for example, lots of memory or the types of applications, such that complete GC is not essential? For example, if cross-region cycles are not collected, maybe it ends up not being a problem. If you were to answer this question, it would settle a debate with a collaborator.
All right, so as a cloud provider, you specify VM shapes. So you say you can buy these shapes and these shapes. And so if a customer buys a 32 gigabyte VM instance and you can leak memory because you run only a short time, then maybe you don't need GC. Right? But if you're a long-running application, you keep your server up for a while, eventually any memory that leaks is going to be a problem because you're going to run out of memory. And you can make your instance size bigger, but then you pay more, but you still run out of memory. So you need garbage collection to help you operate in your envelope of what you're paying for. And if you don't have GC, you pay more money, right? Because you're using more memory than you have to, and you could use a smaller instance size and you could pay less. So the economics are for GC in data center workloads.
Fantastic.
Nice question, Mike.
So maybe a little bit related also regarding memory usage and avoiding memory problems. Wen Wang from the University of Georgia asks, given the memory safety and high efficiency provided by the Rust programming language, do you think that existing system software written in C will eventually be rewritten in Rust? And I'll add maybe, or a language, maybe a future version of Rust. Do you think that future is in our immediate future or not?
So I see a lot of companies making investments in language like Rust or languages like Rust. So I'm hopeful that a bunch of bad C code can be replaced by more principled language that gives you performance as well as safety. And I think like we have a long way to go in computing. We're still in the early ages. there's still huge amounts of software that get huge that are written in C and C++. So replacing that software is hard, but the complexity and the necessity of not having bugs in software makes it more and more likely that some key elements of the runtime can be written in languages that give you more guarantees. And like Rust is an interesting one because it makes programming harder because you're reasoning about these, see, you're only allowed to have one pointer to this thing. And then so it shifts a bunch of burden to, like, instead of running out of memory or having a pointer dereference problem, then you have to spend more time getting it correct from the get-go. So it's an interesting trade-off.
Yep, thank you. So switching gears a little bit to non-technical again. So this is Rachit Nigam again from Cornell, following up on Mary's question about leadership. How can young researchers, grad students, assistant professors, postdocs, be effective leaders while balancing it with the start of their technical careers?
So I find that I get a lot of energy from group activities like that are for the community, right? So I have like served on program committees. When I was early in my career, I managed to do on accident something that turned out to engender lots of good feelings from senior people because I did the best of PLDI retrospective issue. Like, I just wanted to know what people thought were the best papers. I didn't realize that everyone whose paper got chosen would love me. So there are different things you can do that build your community in ways that go beyond your institution, that give you energy. And so what you like doing and what you enjoy doing are like match those things together, and then it won't be a burden to participate in those leadership activities because you'll find time and they'll give you energy. And so like you have to find the right match. And so for me, like I really enjoyed serving on program committees. So I did quite a lot of that, and maybe I did too much, but I got a lot of energy from interacting with my peers at program committee meetings, learning about different styles of research and also different value systems applied to research. And it really helped broaden my vision of what the field was and how you can make decisions about what were important topics and important progress in areas. And then the other thing that I did was I built local community with other women professors in my university at UMass and at UT. So I had a wider range of people who were like trying to do stuff. And so I did some activities with and built groups with that, just for not just for action, but also just for a community, like building connections within my local university.
Cool. Yeah, I definitely resonate with this idea of try to do these things that you need to do anyway, but make them mean more to you by seeking that overlap, you know, in the leadership and in the research side. I think that's really good advice. Okay, so let's see. Next question. Santosh Nagarakate from Rutgers University asks, there is a lot of vertical integration in computing platforms today. How do you think, from your vantage point of someone who's worked in architecture, operating systems, PL, compilers, the whole stack, how should the PL community adapt to this?
So I think some of the most impactful PL work solves problems in the programming language. Like, I didn't do this very often, but other people, you solve a programming problem that people are having. Like Java is portable. JavaScript was a better programming language for the web than HTML. So these are problems that people are having. So look at what are the next set of problems. So I think one area that I think is ripe for improvement that a couple people have been working on at UW and also at UMass is how can you make things that are already essentially a little programming language like a spreadsheet or a survey, how can you make those more accessible to a wider range of people who aren't programmers? And that's the infinity where everybody can make computers do the right stuff instead of random bad stuff, right? Where you have guardrails, you have programming languages, like a spreadsheet is essentially a programming language, but you provide support for it that makes it more accessible to a wider group of people. Or you look at like a lot of end-to-end systems, like you'll see an architecture paper, oh, I need to reach down and tweak the programming language a little bit so they can use the persistent memory. And then they do crazy stuff because they're not programming languages researchers. So I would encourage programming languages researchers to go partner with architects and OS people who are trying to use these new hardware so you can have reasonable abstractions for how these things get used instead of some random thing, someone who's never thought about programming language design. But that requires giving up your beautiful theories and solving like the real practical problem that some developers are having or the wider humanity is having, trying to get computers to do useful stuff. And so I think there's a huge amount of opportunity there for us.
You're making me think a little bit when you say that about this sort of coming wave of quantum computing, where the whole model of computation is very different. The hardware is quite wacky. And so thinking all the way at the level of the programming language down to this hardware is a really interesting gap to cross. Let's see, I have a question from Cole Schlesinger, who's at Akita Software. Working in industry, how do you structure collaborations with academics to navigate concerns around, for example, NDAs and intellectual property?
So one of the easiest things is to just partner with them on their open source implementation with their professor. And so that's the easiest way, because then there's no IP or whatever. So, and then the next easy way is to invite interns, and so the IP is yours, but that's harder because you have such a short amount of time, and typically the student needs to keep working on the project after they leave the internship in order to get a publication. And so in that case, you have to manage that. And so like Google, if you're working on internal Google software, of course, Google owns all of it. But this year, for instance, because nobody's allowed to come to Google because we're all working from home for the rest of our lives, apparently, then in that case, all Google intern projects this summer are open source. So that will make sure that all that work gets to be absorbed by the wider community. And so maybe, and we already had some of that, but maybe that'll be the best model going forward, and that encourages even more participation by students, because then they know they can keep working on stuff when they go back to their university, that they don't lose that opportunity. But there is a trade-off, because if you're working on our cloud system and making it better, you can have an enormous impact on all the Google Cloud users. And so if you're working on an open source project, it may or may not have the same kind of problems or the same kind of impact, depending on which framework and how widely used it is. It just depends, right? But if you're working on something inside of Google, you have a chance for higher immediate impact, but maybe less research impact.
Let's see. So I'm going to do one more question because we have another AMA right after this one. So unfortunately, there's going to be a few questions unasked. And it's from Na Meng at Virginia Tech. And she writes, I have seen more and more PL papers adopting AI to solve PL problems. How does the community evaluate the research novelty of such papers in comparison with pure PL technique-based papers? And if I could maybe add to that a little bit, people will submit such papers both to machine learning or AI conferences and to PL conferences. So maybe my broader rephrasing of the question is, how do we live in this new world where AI is a huge part of everyone's toolbox?
So it's interesting because a lot of the tools that we use AI to improve on, like schedulers and compiler optimization choices, that those a bunch of humans have highly tuned those systems. So in work where you do something different because you have this ability to reason probabilistically or with more data and a bigger system, and so that you can actually pose slightly different problems than we've currently posed, I think is that's the real opportunity for combining them. And so I'll have a small plug for a paper with Martin Moss that was at ASPLUS this year, where we did huge page allocation based on lifetime prediction. In that work, we didn't use the standard allocator. We didn't use a free list. We allocated only big pages, and then we broke them up IMIX style into blocks and lines. And and no one had ever done that in a C or C++ memory allocator. And so that's where you really open the new opportunities, where you solve a problem differently because you've got AI to back you up.
So it sounds like in some sense, the answer is that, for the evaluation doesn't have to change. If you're using an AI technique to solve a problem and you do it better than the traditional ways, good for you. That's success for you.
But there's a lot of opportunity if you pose the problem differently. All right, I'm over time. Thank you for all the questions.
Thank you. And now on to our next one.
Many thanks to Kathryn and Mike, and we will go to the next AMA now. Thank you.
Are we off? Do we hang up now?
I think so.
All right. Thank you, Mike. That was good.
That was fun. Thanks. See you at the next one.
Take care.